The James Webb Telescope has recently detected a remarkable 250% spike in Betelgeuse's brightness. Betelgeuse is extremely unstable and is expected to erupt soon, potentially as soon as tomorrow during this broadcast. When it erupts, it could shine like a second sun in the sky. Join us as we explore the depths of space and delve into the mysteries surrounding the celestial giant Betelgeuse, the red star at the shoulder of the Orion constellation. Even if you're not familiar with its name, you've probably seen the magnificent Betelgeuse, a radiant reddish star that shines brightly at the shoulder of Orion, the well-known constellation. Currently, Betelgeuse has been exhibiting strange behavior, building anticipation for a once-in-a-lifetime spectacle. Some speculate that the star is preparing to go supernova, but the exact timing is unknown. Betelgeuse is so vast that if it were at the center of our solar system, its outer surface would extend to the Sun. Due to its relatively close proximity to our galaxy, Betelgeuse is classified as a semi-regular variable star. Its brightness fluctuates dramatically as it moves toward its eventual collapse in a supernova explosion. Unlike most stars, this massive and observable star continues to fascinate us even after it has left Jupiter's orbit. Unexpected swings in Betelgeuse's brightness have heightened interest in recent years, although we still don't fully understand why it's behaving so strangely. The unusual behavior began in 2020, with the closest red giant star to Earth now pulsating at twice its usual speed, lighting up the early evening sky in the southern hemisphere. This unusual behavior provides scientists with unprecedented insight into the demise of stars as Betelgeuse transitions rapidly between bright and dim states. In 2019 and 2020, Betelgeuse underwent a period known as the Great Dimming. Betelgeuse's brightness has occasionally increased by more than 50%, and on May 20th, 2023, a Twitter account tracking the star reported a 142% increase in brightness. The most recent updates show a 150% increase. If you live in the southern hemisphere, you can easily see Betelgeuse shining brightly in the early evening by looking for it at the shoulder of the Orion constellation. In the northern hemisphere, it's visible when the days get shorter. Astrophysicist Andrea D. PR from the Harvard-Smithsonian Center for Astrophysics notes that Betelgeuse currently ranks as the seventh brightest star in the night sky, climbing 3 places from its usual position. Dr. Sarah Webb of Swinburne University of Technology in Australia points out that one of the most amazing aspects of Betelgeuse is that we can witness the last stages of a big star's life in such detail. Observing Betelgeuse's behavior helps us learn about the red giant phase before stars explode as supernovas. When Betelgeuse eventually explodes, it could become incredibly bright for about a week, possibly even casting shadows at night. This potential spectacle has attracted the interest of both amateur and professional astronomers who are eagerly anticipating a unique event. One day, Betelgeuse will end its life in a supernova. Since we are only 650 light-years away, we have the best view of this cosmic explosion. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Pajero Astronomers and Astronomy Club, notes that people have long been fascinated by Betelgeuse. It has been going through changes in brightness for a long time, with ancient cultures, including Aboriginal Australians and Greeks, noticing this pattern thousands of years ago. Normally, Betelgeuse's brightness cycle lasts around 400 days, but currently it's changing much more quickly, about every 130 days. This unusual behavior started in 2019 after Betelgeuse ejected part of its outer atmosphere. Although these changes in brightness are not typical, they do not necessarily mean the star will explode soon. According to a paper by Dupree and other scientists from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its usual brightness cycle. Since Betelgeuse is about 10 million years old, its rapid evolution means it is nearing the end of its life. When its fuel runs out, its core will collapse, resulting in an explosion that could outshine an entire galaxy. Astronomers at the University of Portsmouth, including an associate professor who wrote a book on supernovas, state that while supernovas are unpredictable, we have no idea when Betelgeuse will explode. Despite scientists' best efforts, very few supernovas have been observed throughout human history, making it unlikely that anyone alive today will witness Betelgeuse's explosion. Before Betelgeuse can explode, it needs to complete several fusion processes involving helium, carbon, oxygen, silicon, and iron. Currently, it is fusing helium into carbon in its core. Eventually, Betelgeuse will use carbon and helium to form oxygen, and the cycle will continue, producing heavier elements like iron. The star will collapse under its own weight due to gravity, eventually becoming a black hole or neutron star. Astrophysicist Jared Goldberg from the Flatiron Institute notes that Betelgeuse will eventually blow up, but the timing could be in the next 10,000 to 100,000 years. Historical records suggest that Betelgeuse has been getting redder over the last 2,000 years, indicating that it became a red supergiant relatively recently. This suggests that it may take a long time for the star to deplete its fuel completely. According to Jason Evar, a star and historical astronomy scholar at West Virginia University, Betelgeuse is not expected to go supernova very soon. NASA also predicts that Betelgeuse will not explode for another 100,000 years. Heidi Morris suggests that rather than assuming it will happen soon, we should let Betelgeuse inspire scientific advancement. Dr. Sarah Webb reminds us that we cannot be certain about the timing and should hope for some luck. We are observing Betelgeuse in the past, and it's possible that it has already exploded, but this is far from definite. Historical experiences show that scientific expectations can be challenged, as seen in 1987 when a blue star in another galaxy exploded, surprising the scientific community. Although it's unlikely that Betelgeuse will blow up anytime soon, the next time you're under a clear night sky, look at the constellation of Orion and admire Betelgeuse. Appreciate the mystery it represents in our vast universe. Its behavior has allowed scientists to learn more about how stars die, and there is still much to discover. Betelgeuse, officially known as Betelgeuse, is a fascinating subject in stellar astronomy due to its massive size and unpredictable behavior. It is classified as a red supergiant, one of the largest types of stars in the universe. Red supergiants are distinguished by their enormous radii and relatively low surface temperatures compared to other stars, which give them their characteristic red color. Betelgeuse is located approximately 650 light-years from Earth, making it one of the closest supergiant stars to our solar system. One of the intriguing aspects of Betelgeuse is its variability. As a semi-regular variable star, its brightness fluctuates in a cycle that can span several months to years. This variability is not entirely unusual among red supergiants, but Betelgeuse's dramatic changes have captivated astronomers for decades. The star's brightness variations are attributed to complex interactions within its outer layers, where convection cells transport heat and material. These interactions can cause the star's outer envelope to expand and contract, leading to periodic changes in its observed luminosity. In addition to its variability, Betelgeuse's size is extraordinary. Its radius is roughly 1,000 times that of the Sun. To put this into perspective, if Betelgeuse were placed at the center of our solar system, it would extend beyond the orbit of Jupiter, encompassing all the inner planets and possibly reaching as far as Saturn. This immense size contributes to the star's relatively cool surface temperature, which is about 3,500 degrees Celsius, 6,300 degrees Fahrenheit, significantly cooler than the Sun's surface temperature of around 5,500 degrees Celsius, 9,932 degrees Fahrenheit. Betelgeuse is also part of a group of stars known as supergiants, which are massive stars that have exhausted the hydrogen fuel in their cores. These stars are in the late stages of their stellar evolution and are characterized by their enormous size and brightness. Red supergiants like Betelgeuse are thought to be in a transitional phase before they eventually undergo a supernova explosion, marking the end of their life cycles. The exact mechanism behind Betelgeuse's recent brightness spike is still under investigation. However, scientists believe it could be related to changes in the star's outer layers or internal processes. One hypothesis is that the star might be experiencing an increase in convection activity, which could cause temporary brightening. Another possibility is that Betelgeuse could be expelling material from its outer envelope, which might reflect more light and contribute to the observed increase in brightness. The potential for Betelgeuse to go supernova is a subject of considerable interest. A supernova is a powerful explosion that occurs when a star exhausts its nuclear fuel and its core collapses under the force of gravity. This explosion releases an enormous amount of energy, outshining entire galaxies for a brief period. The core collapse supernova, which is expected to occur in red supergiants like Betelgeuse, is one of the most dramatic events in stellar astronomy. The exact timing of such an event is difficult to predict, but astronomers use various models to estimate the likelihood and timing of a supernova. Current models suggest that Betelgeuse could go supernova within the next 100,000 years. However, due to the complex nature of stellar evolution, predicting the exact timing is challenging. Observations of Betelgeuse's behavior over the coming years could provide valuable data that might help refine these models. The star's unpredictable variability and recent dramatic brightness changes could offer insights into the final stages of stellar evolution leading up to a supernova. Studying Betelgeuse is crucial for understanding the life cycles of massive stars and the processes that lead to supernova explosions. These explosions play a vital role in the universe by dispersing heavy elements into space, which contribute to the formation of new stars and planetary systems. The material ejected during a supernova enriches the interstellar medium with elements like iron, silicon, and oxygen, which are essential for the formation of planets and life. In addition to its scientific significance, Betelgeuse has captured the public's imagination. Its prominence in the Orion constellation and its distinctive reddish hue make it a popular subject for amateur astronomers and stargazers. The star's name, derived from the Arabic term Ibt al-Jawza, meaning the armpit of the giant, adds to its mystique and cultural significance. The interest in Betelgeuse extends beyond professional astronomy, influencing literature, films, and other forms of media. Recent observations using advanced telescopes like the James Webb Space Telescope provide detailed insights into Betelgeuse's behavior. These observations include monitoring the star's luminosity, temperature, and spectral features, which helps scientists understand the physical processes occurring within and around the star. The data gathered from these observations contribute to our broader understanding of stellar evolution and the dynamic nature of massive stars. Betelgeuse's potential supernova event is also of interest to astronomers because it offers a rare opportunity to study a star in the final stages of its life cycle. Observing a supernova in real time provides valuable information about the explosion mechanisms, the distribution of elements, and the impact on the surrounding interstellar medium. Such observations are critical for testing theoretical models and improving our understanding of stellar and galactic evolution. The study of Betelgeuse also highlights the importance of long-term monitoring of celestial objects. The star's variability and potential for a supernova emphasize the need for continuous observation to capture transient events and understand their implications. Advances in observational technology and data analysis techniques enable astronomers to track changes in stars like Betelgeuse more effectively and gain deeper insights into their behavior. In summary, Betelgeuse is a star of immense interest in the field of astrophysics due to its size, variability, and potential to go supernova. Its dramatic changes in brightness and the possibility of a future supernova event make it a key target for scientific study. The data collected from observations of Betelgeuse contribute to our understanding of stellar evolution, supernova mechanisms, and the life cycles of massive stars. As technology continues to advance, the study of Betelgeuse and similar stars will provide valuable insights into the dynamic processes shaping our universe. The study of Betelgeuse extends beyond its immediate behavior and potential supernova event, offering valuable insights into various aspects of astrophysics and cosmic phenomena. One significant area of research influenced by Betelgeuse is the understanding of stellar nucleosynthesis, the process by which stars produce elements through nuclear fusion. As Betelgeuse evolves, it will go through several stages of nucleosynthesis, each contributing to the chemical enrichment of the universe. This enrichment is crucial for the formation of subsequent generations of stars and planetary systems. When Betelgeuse eventually undergoes its supernova explosion, it will eject a vast array of elements into the interstellar medium. This ejected material includes both newly synthesized elements and remnants of the star's core. The distribution of these elements across the galaxy plays a fundamental role in the chemical evolution of the universe. By studying supernovae like Betelgeuse, scientists can better understand the abundance and distribution of heavy elements in different regions of space. Another area of research connected to Betelgeuse is the study of cosmic rays. Supernova explosions are known to be sources of high-energy particles called cosmic rays, which travel through space at nearly the speed of light. These particles can impact planetary atmospheres, influence climate, and even affect biological systems on Earth. By analyzing the remnants of Betelgeuse's supernova, scientists can gain insights into the production and acceleration of cosmic rays. Betelgeuse also serves as a natural laboratory for testing theories of stellar physics. The star's extreme properties and behavior provide a unique opportunity to test models of stellar structure and evolution. For example, the complex dynamics of Betelgeuse's outer layers and its variability challenge existing models of convection and mass loss in red supergiants. Researchers use observations of Betelgeuse to refine these models, improving our understanding of how massive stars evolve and ultimately explode. Moreover, the study of Betelgeuse highlights the importance of multi-wavelength astronomy. Observations in different parts of the electromagnetic spectrum, such as optical, infrared, and radio, reveal different aspects of the star's behavior and structure. For instance, infrared observations can penetrate the dust and gas surrounding the star, providing a clearer view of its outer layers and material ejected during outbursts. Combining data from various wavelengths allows scientists to build a more comprehensive picture of Betelgeuse's activity and its impact on the surrounding environment. The interest in Betelgeuse also underscores the significance of international collaboration in astronomy. The data collected from multiple observatories around the world contribute to a global effort to understand this enigmatic star. Collaborative projects and shared resources enhance the quality of observations and foster advancements in astronomical research. In summary, Betelgeuse's study impacts various fields within astrophysics, from stellar nucleosynthesis and cosmic ray research to testing theoretical models and employing multi-wavelength observations. The star's behavior provides a valuable opportunity to explore and understand the fundamental processes shaping our universe, making it a focal point for ongoing research and scientific discovery.